So let's go through the installation of the decanter centrifuge. Let's see the main components. We have the barrel and the screw. Inside the barrel we have a bearing, small bearing, and the tip of the screw, you see they have a conical shape. The tip of the screw fits inside the inner bearing and allows it to rotate. The action is that fluid is injected inside the screw and it comes out through these holes. Inside the space within the barrel, as fluid is injected, it fills up this portion here. It is pressed towards the extremities of the barrel, and as soon as it reaches this level, as more fluid is injected, the solid stuff will be pushed, scraped, and come out from this hole, and the remaining clear fluid is supposed to come out through two tiny holes in the cap of the barrel. Okay, so this is the complete chamber, closed. Fluid is injected here, it spins, it is pushed towards the edge. The solid stuff comes out of here, the liquid comes out of these two little holes. You can go and check on the internet how the decanter centrifuge principle works. Now the cap, we have applied some silicone so that it can seal on top of the barrel, and we have a series of screws here to tighten it in place. So maybe first thing to do is to apply the silicone, let it dry, and then we can go for the assembly. First assembly is a metal tube with a pulley that will be inserted inside the screw. So again, fluid is injected right here, and this pulley here connects with a timing belt to the motor, and this is what allows the screw to turn inside the barrel. So first thing is the assembly of this 3D printed pulley. It has to be press fit, and in order to do that, it is better to heat it up, apply some temperature so that it becomes softer, and then it can be hammered into place. This tube goes over the cap inside the screw, and now this piece assembly is complete. As you can see here, this part turns independently, which is turning the screw inside, and there is another pulley here that rotates the whole barrel. So both rotate, and inside the screw rotates at a slightly higher RPM. Okay. Once we've done this, we go to the assembly of the base. This is one 3D printed part that holds everything together, and at the bottom of it there is another small bearing. The motors will be installed on both sides, and a timing belt is used to connect the motor to the pulleys, every motor to each of these pulleys, as you can see. And the barrel sits on top of the small bearing, which allows it to spin freely. So here's the motion of the barrel, and here's the motion of the screw inside the barrel. let's go and install the motor, which is the second important operation. The motor is held in place with screws. We didn't have a good size screw, so these are a little too long, but it does whatever it's supposed to do. Here's a chuck for the motor, 2 aluminum pieces. Put those 2 in place. And why we do this now? It's because the screws are too long, and once the barrel is in place, we cannot fit them inside. So this has to be done now. Place the motor inside the chuck. And tighten everything in place using bolts. At this moment we have to keep it a little loose, because we have to attach the timing belt to the pulleys and adjust the tension, which is very important. Talking about adjusting the tension, we have 3D printing some spacers of different size that mount on top of the screws, and these can be, we can use a series of those to have the precise distance to provide the timing belt with the proper tension. We can insert the barrel into the structure. The barrel sits on top of its own bearing. And then we have to mount the cap on top of this with the larger bearing that will support, will give an extra, a secondary support for the barrel. You can tighten the screws for the barrel now, but if you don't want to do that, you can do it after you install the cap with the large bearing, assuming that the large bearing has been press-fitted into this plastic plate. Now everything is in place. The inside screw can turn by actuating on this pulley, and the whole barrel can also spin at a different speed, supported by this large bearing and a small bearing inside the main structure. Now we hold this plate in place with screws. We have designed it for 4 screws for now. I'm not going to put all the screws in place because this is just a demonstration, but you get the idea. There's 4 screws. Let's put just another one here to have a more sturdy assembly. So suppose this screw has been tightened well, and then we can go through this hole and assemble and tighten the cap of the barrel in place. So there's a series of screws, and we go one by one. We install a screw, and then we tighten it with the key, do a slight rotation until we see the other hole, and continue the process until all the screws are in place, and so that we can seal the barrel. Once this is done, we can go ahead and assemble the belt. Suppose that this motor drives the barrel inside. As you can see, make sure that the belt is parallel to the plane, and then make sure that you have the right spacers to adjust the tension, and we can tighten the motor in place. We can do the same on this other side. Again, these screws here have to be installed before the main structure that goes inside, and there's a belt that runs from the top pulley here to the second motor. We're not going to go through that because it's exactly the same process. Once this is done, the last piece is the cap. There is another small bearing right here that will hold the screw in place. So the screw in place, the screw inside the barrel is held by one bearing inside the barrel that we saw at the beginning, and the second bearing on top of it. And we go ahead and tighten this, fix this in place using screws again. There we go. Suppose everything is nice and sturdy with two motors. One motor drives the barrel. This other motor on the right would drive the screw inside. And this is the tube that goes through the barrel to inject fluid into the system. The fluid, the clarified liquid, comes out through this little hole. And again, the solid material is ejected from the inside or the lower part of the barrel through this hole right here. So I have the clarified liquid ejected here and the solids ejected from that hole, that triangular hole right there. This whole system can be mounted on top of a bucket that will collect the solid material, and another tube could be installed here to drain the remaining fluid.